let's get going. So, hi everyone, welcome to today's SQL Office Hours session, the last of 2020, and what an interesting year it's been. So I hope you've all been keeping safe and well and are managing to survive these strange times without any issues. Now, many of you may have seen that recently we've launched Oracle Database 21c. So there's been lots of activity on Twitter. Various people have been asking me questions about it. So I thought this was a good chance to kind of recap some topics, answer some of the common questions, and give you some time as well to ask your questions about 21c that you may have. So start off with first and probably most interesting question: where can you actually get this? Where can you access 21c? So currently, it is available on Oracle Cloud and only on Oracle Cloud. So if I just go over, I'll show you what's actually happening here. So you can create a 21c instance in Oracle Cloud either as an ATP, a free ATP instance, or as a VM, database as a service instance. I'm going to create a free ATP. So let's just go there to create ATP. Let's give it a second or so to load up. And there's just a couple of things we need to enter in here. All we really need to do is give it a name. So let's do that. We'll scroll down and we spot this little toggle here. The interesting thing is this always free toggle. If I flick that, then we can create our always free database. And I will select version 21c. So the only other thing I need to do here now is scroll down a bit and enter my password for the admin user. Nothing else to do. So let's just create that database. That will start thinking away and building that database. I'll take a few moments to do. So while it does that, let's jump back over to the slides. Next, some of you may have seen that we're calling 21c an innovation release, and you might be puzzling a little bit over what exactly innovation means. So just to kind of show you where we stand at the moment. So 19c is our current long-term release. And our next release after this is 21c, which is our innovation release. Now, at this point, some of you might be thinking to yourself, well, hang on, 19 to 21? What happened to 20c? Where's 20c? Wasn't that supposed to be in the middle of them? And yes, we did originally plan to release 20c this year, but as you probably all noticed, things have been very strange this year, and I doubt many of you were thinking of upgrading your databases at all. So we to reflect this, we thought, well, there wasn't really much point pushing a new version out, which very few people are actually going to even look at, consider moving to, because they've got more important things to worry about. We decided to defer it and essentially kind of roll 20c into 21. So a lot of the stuff that's in 21 is pretty much the same as 20. We've got, spent some time fixing it. There's a few other extra bits and bobs. But if you played with 20c at all, a lot of the stuff that's new in 21 will be familiar to you to some degree. Now, one of the big things, what's this long-term versus innovation release? This really comes down to how much support you get for those releases. They are both perfectly happy for you to use them in production should you wish to, but 19c, the long-term release, is the one that you will have support for the ongoing future, for many years to come. So at least until and past whenever our next long-term support release, that's currently slated to be 23c, I believe. So that will keep you supported. 21c, you will only get 2 years worth of support, and there won't be any ability to kind of extend that support in any way whatsoever. And you might go, well, why have we got these two different releases? Well, we know that we moved to this kind of annual release approach back in 2018 with the launch of 18c. And the feedback we got from a lot of customers is like, we don't want to upgrade every year, right? We struggle to upgrade once every 3 or 4 years. Telling us that we have to upgrade every year, something that we've struggled to do. So to kind of recognize and reflect this, we've got our long-term support release. And so for the customers who want stability, you don't want the hassle of upgrading every year or every couple of years, you'll stick on 19C and then probably move to the next long-term support release, which is 23C. But we wanted to keep getting new features out there. You know, some of you might want to take advantage of new features that come along, or you got your upgrade processes, you know, nailed down smoothly enough that you can actually manage to upgrade regularly. So we've got the concept of these innovation release, where you want to move a bit faster, you want to keep up with the latest database versions, so you could take advantage of the features there, recognizing, however, that you will need to upgrade, you know, regularly if you want to stay supported. So questions, any questions or comments on that before we move on? As I say, if you want to know full details on this and full details about how these release schedules are working, check out the MOS notes. All right then, so one thing, so Auradip, when will 21C be available for on-premises? So a good question. The answer is sometime next year. I don't know the exact timescales beyond that, but it will be available in 2021. So it, you know, should be, you know, early half, but I don't know exactly. Any other questions or comments? No? Okay, so we're talking about, so we're saying that 21C is a innovation release. You've only got 2 years worth of support for this. So you're going to be forced to upgrade and so on. Someone at this point might be thinking to yourself, well, I'll just give 21C a miss then, right? You know, I don't want the hassle of having to upgrade, and I will just worry about it. We'll move to the next long-term support release when that rolls around, right? And first up, that is a valid approach should you wish to go for that. But I would suggest that you check out 21C still. A couple of reasons. First up, I will get on my high horse just a little bit and say, no matter what your position as an organization is with regards to upgrades, I really think it's worth investing the time in getting the process nailed down so you can do this regularly. Maybe not every year, but probably every couple of years. Several reasons for that. Obviously, you can take advantage of the new features. Each new release tends to come with various performance advantages, which are just kind of built into the database as well. So it tends to be a bit faster on each new release. Also, the more often you do something, the easier it becomes. You know, it's kind of a bit of a chicken and egg situation. We go, upgrading is hard, so we delay it, and the longer you delay it, the harder it becomes to do it. And so the more you delay it, the more you put it off. If you just kind of bite the bullet and say, we're going to do this, and get in a position where you do it regularly, you iron out the problems, you get used to the process, you get used to actually doing it, and it just becomes more part of something, you know, your organization's DNA to actually do that. So, and finally, the more frequently you upgrade, the easier, the smaller the gap is. So, you know, if you go from 19 to 21, that's a small jump. You know, it's one version's jump, basically. If you are currently on 11G or something earlier, I don't want to hear about it if you're on something earlier, but I know there's many people still running 11G. Going from 11 to 19 is quite a big jump, right? And the bigger the jump gets, the scarier it gets as well. So again, the more frequently you can stay on top of this, the more you can de-risk it. Part of the goal of things like agile and continuous delivery is to do changes regularly so that you actually get used to dealing with them and used to dealing with what happens if they go wrong, because changes just do go wrong from time to time. And the more streamlined you can make that process, the safer we'll all be. And you know, if you're thinking this is just an excuse, I'm just trying to get you to upgrade the Oracle database, yes, I'd like this. I think this applies to the entire technology stack, right? Not just the database, but the operating system, whatever you use in the middle tier or your middleware. This is something organizationally that you should be looking at generally. But I understand a lot of you are not in a position to do that or not willing to do that. Management aren't willing to give you time and effort to invest in these things. So if you are in that position, you'll stick with 19. And that said, even if you're going to, you know, not upgrade to 21 soon, which wouldn't surprise me, I still recommend you check it out. Why? Well, this is one of the best features for the best versions for developer features for quite a long time. There is a lot of cool new toys and tricks for developers, SQL and PL SQL features, and some of which are really big kind of game-changing features like SQL macros. So even if you don't actually plan to upgrade, I still think it's worth checking out with your free ATP instance, checking out what's going on there, seeing how that works, because then you can see what's coming, plan about, okay, when we get here, these are the features we could take advantage of. Maybe even it becomes easier to make a business case. It's like, these SQL macro things are really cool. They can help us be more agile, deliver quicker, and so on and so forth. So we will upgrade and take advantage of these. So as I said, there's lots of cool things here for developers in 21. A lot of these I have talked about in these sessions in one way or another before. I'm going to focus on some of these in the kind of bolded ones, so SQL macros, JSON improvements, and JavaScript execution in the database. Okay, so see this question from Anonymous. Oracle XE new version will come to. Yes, we plan to have a release of 21C XE, so that is planned and in the works. That will come after the on-premises release when that is actually released. Okay, cool. All right then. So let's start off with kind of a common problem when you're writing SQL queries. So we've got a fairly simple query here. What we're trying to do is find all the order items where the total paid is greater than some value. And we store the unit price and quantity as separate columns. To find the total paid, you need to multiply them together. So pretty straightforward query. But this computation, find the total paid for each item, is quite common. It's likely you'll run it, write it in many, many different queries or statements throughout your database. And whenever you have to do the same thing many times, there's always this chance you'll make a mistake, accidentally add them together instead of multiplying, or something daft like that. So when you write new code, you have to test it thoroughly, make sure there's no silly unexpected bugs that come in. But also over time, this computation starts out nice and simple, but it tends to get a bit more complicated. As your business grows, you might have to start taking international payments. So you have to worry about currency conversions. How do we convert this from or to the payment currency to whatever your business currency is? Maybe you need to add or remove sales tax from the result here. How do you do that? What's the exact rate that you use, and so on and so forth. So as you start adding these more complications in, it becomes more and more likely that someone's going to make a mistake and do it incorrectly every time they write it. So you want to make this a reusable piece of logic, right? You want to make a function, we'll get the total paid function and use it in our query, so then we can ensure everyone is calculating this in exactly the same way. So makes our system more reliable, reduces the amount of effort we need to go to testing and things like that. So pretty good, right? Seems pretty straightforward. We'll just stick that function in write the function, stick it in our query like this. But what happens? Oh no, the query gets a lot slower. It's like 100 times slower after changing from just multiplying them together to sticking that logic in a function. It's like, well, why is this? So why, if we take that multiplication just out of our where clause and put it in a PL SQL function, does it get so much slower? So one of the big problems is we have the context switch. So when you've got your calculation just in SQL, it's running in, Pablo's got there eventually, context switch. So the SQL and the PL SQL engines are different runtime engines. So we just do it in the where clause, quantity times price, then we stay in the SQL execution engine the whole time. But if we have a PL SQL function that we call, then for each row, we have to change from the SQL engine to the PL SQL engine, run the computation, pass the result back again, and then continue on to the next row. So we have a lot of this back and forth from the SQL to the PL SQL runtime engines. And this can really, really stack up and make your statements a lot slower. So this gives you kind of like a bit of a bit of a dilemma. Do we go for reusable, maintainable code with these PL SQL functions and accept things might be a bit slower, or do we just go out for outright performance? Do we try and make our queries as absolutely fast as possible and avoid PL SQL as much as possible and worry about the maintainability problems later? So, let's see, have a little vote, which side do you sit on? Do you go for performance or do you go for maintainable code? Just say P for performance, M for maintainable if you want to be quick about it. So I see there's a question from Suman here. Cardinality estimates may be off due to functions in the where clause predicates. Yeah, that's another good point as well, Suman. Not only do we have the context switch, but those PL SQL functions are a black box to the optimizer. It doesn't actually know what the result of the computation is going to be, at least by default. So the cardinality estimates are likely to be more incorrect than if we have it just in our where clause. So yeah, another good reason that another problem that can arise. But yeah, it's not an easy decision here, right? And it's something that you quite often have to make on a case-by-case basis, even within an application. There might be some parts of it, you might have your standard function, which you try and use where you can, but there's some queries, some statements where you need that outright performance and you just go, well, forget it. We have to just rip it out and use it in SQL. So not a straightforward answer. Now, there's things we've done over time to kind of help mitigate the effects of this context switch. So back in 12C, we introduced this pragma UDF. So you can add this to a function after you've declared it. And what this does is it reduces the overhead of the context switch. So the context switch is still there. We're still having to do the switches backwards and forwards between the engines. But, it's still there. It's faster than not a pragma UDF generally, but it tends to still be a lot slower than pure SQL. So see, Alessandro is saying function-based indexes, materialized views. Yeah, certainly for something simple like this, where we're just multiplying quantity and price from two columns in the same table, we could use a function-based index. But over time, as things get more complicated, we might need columns from multiple tables, right? What if these values are coming from different tables? You can't then create a function-based index on it. Materialized views, again, they can help, but they tend to only help when aggregating huge data sets. So for fast single row or few row lookup type queries, yes, you could pre-compute it using materialized view, but you're generally adding overhead for minimal benefit there. So there are solutions, you're right, but they've all got their trade-offs, right? There's nothing that, guarantees that it's going to be one way or the other. At least that is until now. SQL macros. So SQL macros can help resolve this dilemma for you. So what these do is they return a SQL fragment, so part of the SQL statement. And these are resolved at parse time. So when you first submit the query to the database takes the contents of the macro and makes it part of the final SQL statement that is actually executed. So from then on, it's as if the function does not exist. So this means you've got a nice maintainable, reusable bit of code with the performance of pure SQL. So pretty nice. So how do these work? Well, SQL macros come in two flavors, table and scalar. So what's the difference? Well, table macros are ones that you use in the from clause. So instead of a real physical table, a view, or a subquery, and so on. Scalar macros are ones that you use basically everywhere else. So in the select clause, the where clause, pretty much everywhere else, it's legal to use a PL SQL function. So that's a high-level difference between them. I'm going to be focusing on scalar macros today. Couple of reasons. So table macros, this whole feature was originally slated to be a 2021C feature. Table macros have been backported to 19C. So if you want to play with table macros, you can do so on 19C today. Scalar macros only in 21C, so they are not being backported. So I've talked quite a bit about table macros in the past. I'm going to talk about scalar macros because they're the new feature, and there's a few interesting things that's worth covering on those. So how do we write them? Write one. Well, you create your function and it returns a string of varchar2, and notice we need to add this SQL macro clause, and I put in there it's scalar. So we could put table or scalar. Table's the default. We're saying this is scalar, so this would replace, we could put this in our select clause, our where clause, and so on. Now, the interesting thing to note here is what we are returning is a string. I have quoted the parameters, quantity and unit price. So it returns the text. And when we call this function, as I said at parse time, what the database does is it looks at the actual text of the parameters you have passed to it and does a find replace, essentially a find or replace of those in that string. So then that becomes part of the final SQL statement that we execute. So at this point, I'm going to jump over to a demo and show you how that. My instance is now available. So you see that was pretty quick. Didn't have to wait too long. I'll get my database connection. We need to download my wallet. I will give it a password. Although I put password in, I never actually need to refer to this again. So obviously save your password, because otherwise you could potentially be in all sorts of trouble. But there we go. Let's save that. I've already got one, and that's got that, hopefully. And now, if we go over here, so here's one of my made earlier. This is one of my earlier ATP instances. You can see I just need to put in my wallet, and I've got my same password as I had before. And there we go. Yep, success, save, connect. Alrighty then. So indirect, can it be some other function like apex item.text? I'm not sure exactly what you're talking about there, indirect. If you could give a bit more detail. I think if you're talking about if it's a provided function like something in Apex, then it's up to the Apex team to do this. If the macros apply to functions you've defined. If you could give a bit more detail about what you mean, I can talk about that a bit more. So Sven, can the scalar macro function be defined in a with clause of the same select statement that uses it? So off the top of my head, I'm not sure. I know we do at the moment have some restrictions or some issues with using macros in the with clause and how they combine. Dev team are working on that, so they all work together nicely. If we've got some time at the end, then maybe we can try that out. But hopefully we will at some point. But I'm not sure. We can check if you want, Sven. All right. Alrighty then, so I've got my ATP instance, it's up and running, and I'm just creating a nice big table. So I'll have my order items, there'll be several million, should be about 4.7 million rows in this table, and we'll just look at how we can tune our query. So that's taking a second or two to execute. There we go, 4.7 million rows, in it goes, and we'll see how many have a total price greater than 60, so about 100,000 of them. And that's pretty quick, 50 milliseconds. So we've decided, this logic, we want to put it in a function, so we'll create our PL SQL function. At the moment, it's nice and simple. We'll just multiply them together. Excuse me. And let's just compare the performance of them. So we've got the pure SQL approach, which executed in no time, and we can see, you can already see the PL SQL approach is quite a bit slower. So 70 milliseconds for pure SQL and 5.8 seconds for PL SQL. So nearly 100 times slower. Certainly getting close to that order of magnitude just by sticking that logic in a PL SQL function. Right. So you can see why people don't want to use PL SQL functions here. Right. So let's try using our Pragma UDF, see how that helps things. All I've done is I've just stuck the Pragma UDF. Otherwise, it is exactly the same function as we had before. I will run that, and you should see it's a bit quicker. So yeah, just over a second. So about a quarter of the speed of a standard PL SQL function, but still more than an order of magnitude slower than pure SQL. It's like, whether this is good enough for you, you kind of have to decide. It depends on where the needs of your application. Let's now make our macro. So as I said, notice we are returning this text, or the string in the macro. The database will resolve this to a proper SQL fragment at parse time, I should say. So let's execute that. We've created our function. And now if we compare the performance of all three of them side by side, just to see so you can see what's going on. Let me just kill some of the other windows while that runs. And you can see that the macro approach, a tenth of a second, that's probably just passing overheads there. Let's try running it on its own. Yeah, so what's happened there? Why is it? Oh, it's because I haven't set timing on. Set timing has disappeared. There we go. So yeah, back down to basically exactly the same runtime as pure SQL. Whereas UDF, bit over a second. Standard pure SQL function, 5.6 seconds. All right, so not great for the PL SQL functions, but our macro has resolved those problems. It's gotten a lot faster because, like I say, after we've parsed it, it's as if that function does not exist. And going to the point Suman had about cardinality estimates, the optimizer now has visibility of the expression that we've returned. So let's just look at the plans. So I'll do our UDF just because it's a little bit quicker, so we don't have to wait so long, and get the product ID. So we actually have to visit the table. So we've got a hash group by, okay, fairly straightforward. We'll do the same with our macro, a lot quicker. Now, looking at the plans, they look pretty much the same, right? Both doing a hash group by table access. But if we compare them, it's really nice, neat feature I like about SQL Developer. If you've got two plans, you can do this little right-click compare and see what's different. And we can see what's highlighted here. It's to do with how the database has filtered these. So if we go to the one with the macro, we can see we now got some access predicates. Because on the options here, we've got storage full. So we're using Exadata storage indexes. So ATP runs on Exadata, if you didn't know. So that includes your free ATP instances as well. So you are, in fact, using Exadata under the covers of that. So we're using our storage indexes. And the database is able to do that here because it's got full visibility of what this expression is. And if we look at the output rows here, it's got nearly 2,800, so getting on for 3,000 output rows from the table there. We compare it to the pure PL SQL function, it's not able to do that. It's filtering rather than access, and it returns all 100,000 of those rows from the table. So we were able to push that processing all the way down to the storage layer. So, this is particularly if you're using Exadata or ATP, free ATP. The optimizer and the SQL engine can take advantage of these, but just generally the optimizer has better visibility of what's actually going on inside the function because the function essentially doesn't exist from then on. It's less of a black box, and it can come up with better optimizations, better estimates in some cases. Okay. So just a sort of quick question from Anonymous. Is there any difference between count 1 and count star? No, there is no difference whatsoever. The database will, if you do a count 1, the database internally converts that into a count star. If you don't believe me or want to prove it for yourself, you can do a 150D trace and dig out the file, and you'll see something that shows that it does that. They are identical. They work the same. So, there is no performance advantage one over the other. Okay, so let's move on. So now the thing is, someone was saying we could, instead of using a macro, or you could do things like create a function-based index. So yes, that's technology options you have the options you have today to help improve the performance of these kinds of expressions. But you might want to use this function in many different places. And this macro we can now use, we can pass into any table, and we'll still get those advantages without having to do anything special, like create a function-based index or extended stats or anything funky like that. So if we call this just pass in 2 and 5, unsurprisingly, we'll get the answer 10. The database is resolving this to literally 2 times 5. So that is what's executed by the SQL engine. We can also pass in bind variables. And as you can see here, what it does, the final SQL statement looks like this. It's taken the text out of the macro, taken colon quantity, done a replace of that in the string, and that is what's the expression that's executed at the end. We can pass in functions as well. So dbms random. It's not executing the function, finding a value, and using that value every single time. Literally, this function is now part of the final SQL statement you actually execute. So you can see you get different values every single time for every single row. Okay, so it is essentially a find and replace. It's a bit more advanced, a bit cleverer than straightforward find and replace. But if you think of it like that, that will take you a long way for doing it. So seems brilliant, right? SQL macros are the future, and we should just use these all the time and replace all our PL SQL functions with them, right? Well, there's no such thing as a free lunch, and there's trade-offs everywhere. We might still want to call our macro in PL SQL, so not in a SQL statement whatsoever. What happens if we do that? Well, you just get the text back. So that substitution of the values only happens if you call it in a SQL statement. If you call it in pure PL SQL, you will just get the exact text that you returned from the macro. So, you know, if you're going to be using this function in multiple contexts, so both SQL and PL SQL, you could still have a bit of a dilemma here. You know, do you have 2 copies of the function? You know, the SQL macro and the PL SQL version? Do you just write macro and enforce that everyone has to select it when they want to get the results, even if there's no other select statement necessary? Yeah, again, a bit of a debate, something that you'll have to decide internally about how you want to manage these kinds of things. So something to think about there. Next, another important thing to be aware of. What it returns is an expression. So you can see before we had our where clause like this, quantity times price greater than some value. You might think, well, why don't we just try and replace this whole thing, this whole where clause as macro? And unfortunately, you can't do that. Well, you can try, right? We can certainly return the text of this. The database isn't going to complain at this point about creating the function, but if we call it in our where clause, it's going to go, that doesn't work, right? Invalid relational operator or some other error, depending on what exactly you're doing. So it's really just returning one expression. So it would replace a single column, for example, in your select clause or your where clause, and so on and so forth. So you can't use this to kind of generate multiple columns. You can't use scalar macros. You'd have to use table macros to do that. Next thing to be aware of, like I said, these are resolved at parse time, and that means they are implicitly deterministic. So the database has to be able to resolve the value it's returning based on the input values. So if you do non-deterministic things inside your macro, strange things can happen, right? Probably the classic example or most common thing people will try here is putting a SQL statement inside it. So counting the rows in our table. So let's just create that and we'll execute that. We've only got one row in the table, so it returns 1. Right, perfect. Let's insert another row in the table. Okay, we've now got 2 rows in the table. What's the macro going to tell us? Well, we haven't reparsed the query. It's going to stick what it originally had at parse time. It's still going to return 1. Interesting, right? So just like with PL SQL functions, you've got the deterministic keyword. You can add deterministic, but do non-deterministic stuff in there, and strange things can happen. Same with SQL macros. If you've got non-deterministic stuff going on in there, strange things can happen, okay? So be careful, be wary of that. You're not going to get any warnings about it. You know, it just executed it for me. Or at least I don't believe you'll get any warnings. And maybe you'll get some PL SQL warnings, actually. I'll have to look into that. But if we change the query slightly so it forces a reparse, you'll notice it does get the correct result. So it's back to 2. If we go back to the original query, let's just undo that. It's back to 1. because we haven't the cursor cache hasn't invalidated for this, so it's not re-executing it. So be aware of that. This also means if you want to depend on runtime values like bind variable values, it's not going to work, right? You can't pass a bind variable in, inspect its value inside the macro and change its behavior, because that is a runtime thing, not a pass time thing. So very important. You could get tripped up by this if you're not aware of that. So one approach, so instead of doing this, let's say you do want to run a query inside the macro or return the results of a query from a macro. Instead of actually running the query like this, like static SQL, we can just return it as text like that. You can just return count star from T, and now we can run that. And that is like now effectively a scalar subquery. So if we do that and we insert more rows into the table, we see our count now rows function is now doing what it's supposed to do, because this SQL statement is now part of the SQL statement we run. It's not resolved at pass time in the function. Okay, I see some more questions have come along while I've been talking, so let's just take a quick look at these. So Judith, what if the function should execute some more complex code, like for example, selecting from some other table also? Will the SQL macro be able to do that? So hopefully I've just demonstrated that, Judith. Short answer is it can do it, but you're probably going to get unexpected incorrect results as the result of it, okay? Because it will be non-deterministic. If you can take that query and just stringify it and return the entire query, then you can get what you wanted to do. But generally, if you're just running static SQL inside the macro, unexpected things can happen. Okay, you can do it, but be prepared for strange outcomes. Okay. What I meant is, can I use whatever function in SQL macro? Is there some restrictions? You got the answer. Okay. All right. I'll take that, Indrek. All right. Any other quick questions or comments before we move on? Spent a bit longer on that than I expected, but this is a great feature, and there's some things you do need to be aware of. Like I say, it's not completely free lunch. There is still some trade-offs, but I still think this is a brilliant feature for many of us. So let's just recap those quickly. So as I say, database resolves this at pass time. So that means at runtime, there is no context switch. This can give big performance savings, avoiding that. In a lot of situations, avoiding that context switch itself is enough to give you the performance gains you need. But secondly, and perhaps just as importantly, the SQL engine now has full visibility of that expression. It's no longer the PL SQL black box it was before, which means things like, if you are running ATP Exadata, we can push that down to storage indices. It can mean in some situations the optimizer is able to come up with better plans because it's got a better idea of what the row estimates are and things like that. Now, the consequence of resolving at pass time is it means that they are implicitly deterministic. The database has to be able to resolve the text that it's going to, what it's going to return at pass time. You cannot depend on runtime behavior. If you do, strange things will happen. And yeah, just prepared for weirdness. Finally, while you can call these in PL SQL, it doesn't give the result that you perhaps might want, which is the actual result of the computation. It gives you literally the text it would return. So be aware of that. If you need to call the function in SQL and pure PL SQL, you're going to have to debate and think about how you actually want to handle those. So Sven, last question on this before we move on. So Sven, can the same macro with different inputs be used several times in the same statement? Yep. I mean, if we just go back, let's just go back to this one quickly. Where was I? If I just copy this and do that, and I'll just change that to 10. You can use it. There you go. So we've got 10 and we've got 20. You can use it many times and it will resolve it correctly. So that's absolutely fine. Yes, you can do that. All right, then. I've got more things I want to talk about. So if you've got more questions, put them in. But let's move on because time's flying by today. We'll talk a little bit about JSON. So there's a lot of JSON enhancements coming in 21C. One of which is the JSON data type. It's one of those nice things, but it's also not that interesting to talk about really, because you just say use the data type. It's better and faster. So there's some other more interesting features which have a bit more explaining. So let's say you've got some JSON arrays and you want to find all of them which contain a particular value. Now, the problem with this is the array that a value might be in different positions in the array. So you can see it's the first, second, and third elements of these arrays. So how do we write the query to fetch them out? Well, you could do something like this. For each individual position, check if it's there. In order to do that, you need to know the maximum number of array elements in the array for the entire table. Not always practical. We could do JSON table, which takes the array and converts it into rows. This will do it too, but may not give the output that you want. And of course, we're taking something, generating lots of rows just to filter it back down again. Generally, that's a bad idea in SQL. Generally, that can make things slower. So what ideally you want to do here is something like this. You can use JSON exists with these search expressions. So I don't have time to explain them today. If you want to know more, look them up in the docs and so on. But you can do all sorts of clever and interesting things here. And what this is doing is saying, oh, that should be array star, not array 0. I'll mess that up. I'll fix that later. Find any array which has the value 42 in it. Pretty straightforward, right? There's a potential issue here, and that is indexing. How do we get good performance out of this? We could create a JSON search index, but that indexes the entire document. If it's a large document, it's a large index, it's not going to be that efficient to search. So in 21C, we've added what is called a multi-value index, which allows you to index individual array elements. Very neat. I'll show you how those work in a minute. While we're on the subject of arrays, you might want to change some of the values. Let's say we want to update all those values 42 to some other value, 3.14, whatever. And this is a bit of a head scratcher. It's like, how do we do that? How do we find that? So in 21, we've added this JSON transform function. And what this allows you to do is manipulate individual elements of a JSON object. So in this case, it'll search for any array element with a value 42 and replace it. So demo time again. Let's show some of these examples. Let's jump back over here. So let me just create a little table with our arrays in, and I'll create a JSON search index on that. So any questions or comments while we wait for that to run? Okay, there we go. Excuse me. Okay, so we could search by position of the array. This is only going to return me one row because we're searching for the first element. You have to all them together. Not very good. We could use JSON table to generate the rows out, filter them back down. Works, but might not be the fastest approach in the book, right? Or we can do this lovely little JSON exists trick to filter out the values, and that's all the arrays we want here. That's what we're searching for. So the issue is, let's just get rid of these auto traces. Let's just run this again. So we are using the JSON search index to, let me run it again. There we go. Using JSON search index. And if we look at this buffer gets, how much IO we're doing, getting 3 rows and doing 6 IOs to do that. That's a lot of work, right? Relatively speaking. Like I said, the problem with the JSON search index is it is indexing the entire document and then essentially using Oracle text behind the scenes to split it up into its components. May not be the most efficient. Hopefully, faster than a full table scan, but still not targeted efficient like we want. So we've got these multi-value indexes in 21C, which target the array specifically. Now, note, it only targets scalar values, so number, date, string, and so on. So we need to say these are a number that we're pulling out here. We do our multi-value index, I did pin that, and we run our JSON exists again. Oh, fantastic. JMI, JSON multi-value index. And the amount of work we're doing has dropped considerably because we are now only indexing that array rather than the entire document. So this can be much more efficient for searching JSON arrays. Potentially very useful if you store JSON in your database. Okay, so you can do all sorts of funky things with these JSON exists. You can do search paths with values greater than 40. They can use the index as well. All right, so let's say we want to change all those arrays with a value 42 to 3.14. So I can use JSON transform. So there is a lot of options for this. Set is like SQL merge, upsert. Insert if not exists, update if exists. So I'll run that and it will change all of those values to 3.14, as you can see, 3.14. Pretty neat, pretty nice. So this JSON transform is, there's a lot of functionality to it. We could also add elements. So set is insert if not exist. So we're going to add elements at position 99, the 100th element, put that in. What happens? We've then blown out the size of our array. We've now got 100 elements in our array. Oops. Maybe not what you wanted to do, right? Okay, so let's just undo that. You see, we've added that one in, but we've also filled in everything between our previous last element and that with null. Probably not what you wanted. So if it's not there, how do we prevent it? Well, there's these on missing and on exists and on null clauses. And there's lots of power and lots of cool things we can do with these. So what we're saying is, if there is no element in position 99 in the array, raise an error to stop us doing that. So as I said, JSON transform has a lot of options, a lot of power. I will just show a few of them very quickly because there's loads of these, and if I went through them all, it'd just be a bit dull, right? I'm just going to give you a flavor of what it can do. So what I want to do is add a attribute called new. I will remove the second element. So JSON indexes are 0 index. So position 1 is the second element, and set the 99 position 99 100th element if it is present, but only if it is present. So at the moment, new doesn't exist. Those are the values for the second element, and there is no 99s. So to only set it if it exists, we can use this ignore on missing. So say it's not there. And we can chain on those other commands we want to do as well. Insert, as you kind of might expect, adds that element in, and remove is a bit like delete. Remove that second thing from the array. So let's just run that, and we can now see we've updated it. So we've got our new attribute. We removed the second element. So this was the middle element of these arrays. They got 3. They had 3 previously. So essentially, we've just shifted those over. You see, if I compare those side by side, you'll see that the second element has now changed, and we've only got 2 of them. We haven't replaced it with null. We've removed it entirely from the array. It's gone. So, like I say, that was just a quick idea of the various things you can do. There's several more of these commands and lots of options for the on missing and on existing clause. So that was to give you a feel for how that works. Questions, comments on that before we move on? If you've got questions, just put them in QA. I will do a quick recap on that if you are, well, we do. So JSON summary. First up, as I said, there is an optimized JSON data type. Actually, I'll go back. I don't think I showed you that. There we go. Just call it JSON. Very simple, nice and easy. So optimized JSON data type. If you are storing large JSON objects in your database, when you get to 21 or above, you really want to use this. It is notably more efficient than CLOB or blob storage because it is optimized specifically for JSON. When it comes to searching arrays, we've now got a multi-value index, which can really help you when you want to find if an array contains a particular value, particularly if it could be anywhere in the array, which is often the case. You don't know exact position. JSON transform is a great way to update documents. In 19, I think it was 19, we added JSON merge patch, which was similar, but much less functional. and in any case did basically a complete replace of your JSON document. JSON transform targets the exact attributes and values that you've found and changes them as appropriate. So this is a lot of power, a lot of cool things you can do with it, but also it's more efficient than updating the whole document, particularly if you've got the JSON data type. There is a whole boatload of other little tweaks and enhancements in there. So if you do work with JSON Oracle database, check those out. Any, not seeing any yeah, JSON transform looks pretty useful from Sven. Yes, absolutely. Like I say, when it comes, if you've got a large object and you want to change just one or two attributes from it, particularly array within an array, very powerful, very cool. Check it out. Lots of good stuff in there for that. Chris, any chance that the JSON optimized binary data type will be backported to 19C as it already exists in 19C as the OSAR format is used for the autonomous JSON database? I'm not aware of plans to do that for the on-premises version, but that doesn't mean it won't happen, but I'm just not aware of plans for that, Chris. Okay, so, you know, if lots of customers demand it, then it may happen, but yeah, that's where it stands at the moment. Okay, oh, Amit, does JSON database have more features which are not in Enterprise Edition? So that's something actually I'll mention very quickly. So you may notice when we're looking at the databases, I've got this autonomous JSON database. What this is essentially a somewhere between the free ATP instance and full autonomous database. So with free ATP, you get 20 gigs of storage. That's it. With full autonomous, you get however much you pay for, basically, right? JSON, autonomous JSON database, you get 20 gigs of relational storage, so traditional tables, but you can also have an unlimited amount of JSON storage using the SODA collections. And the big difference here is it's a quarter of the price of regular ATP, so it's significantly cheaper than regular ATP, so it kind of sits in between those. But otherwise, they're the same. Their functionality, they offer the same features. They have the same things in them. So there are not, it's more limitation over storage and, you know, things like that. Feature-wise, as far as I know, they're the same. I mean, so hopefully that answers your question. All right, one last thing I wanted to cover before we wrap up, and this is a fairly quick thing, JavaScript in the database. And this one I'm just going to go straight to a demo for. So some of you may be familiar, may have heard of the Graal VM project, which we could use to execute JavaScript in the database. It's now here in 21C. Now, note, this is currently unavailable in ATP. I'm having to use my Cloud VM instance for this. We do plan to add it into ATP, but it's not there as it stands at the moment. There's a couple of things we need to do. We have these little funky grants we need to give it. And there's this new object type, MLE language, JavaScript. Yeah, interesting. So that means we can run JavaScript in the database. We'll just run through a couple of these kind of quickly. So we're going to do hello world, we'll get the console, and you'll see we'll get the output. So there we go, hello world, we can pass values to and from PL SQL to JavaScript. So we see my variable world. If we run that, we will get greetings from MLE, hello world. If I change that to SQL office hours, we can pass in that to the engine and get it back out again. We can execute SQL statements. Let me just create a new table, update that. We can execute a query, pass its results back to the engine. We'll get the output there. So we're console logging these, which is a bit like the equivalent to DBMS output.put line, right? It's not something you should do in production systems, but it's nice for a little demo. We can use bind variables to pass those in. One little thing you might be aware of, notice it's got this out format of Oracle DB object, which allows me to say the columns I'm looking for. If you don't use that, by default, you get array an array of the columns in the output. So we execute that. You see, we're accessing column values by position in the array. A bit confusing potentially, right? You probably want to use this thing like this. So we are close to the hour, so I just wanted to show you that quickly and kind of show you that it is there. It's not in free ATP, but you can use it should you wish to. Now, some of you at this point probably like, why? Why do we want to run JavaScript in the database? Right? Good question, valid question. And part of the answer is it's because of you, right? When we first announced the multilingual engine project a year or two ago now, a lot of people in the community were excited and interested by it. And it's partly due to community support that it is in 21C, at least. You know, without people asking for this, it might well have been a few releases later, shall we say, before it reached production. In the more general question, why do you want to use JavaScript in the database at all? Well, there are still some things which it's difficult to do natively in PL SQL or SQL. There's some things which are hard, which you might have had to write a Java routine for in the past. Not many, but there are a few things. So in this case, JavaScript just gives you another option here. Another thing as well, JavaScript is just a hugely popular language. You know, it's topped the Stack Overflow survey of most popular languages for the past 3 or 4, 5 years at least. So a lot of people are familiar with it. And you know, you might have some front-end developers writing in Node.js. They've got some code. It's kind of slow, and a lot of that is to do with network talking from the application to the database and back again. We're losing a lot of time in the network. Now, in the ideal world, to really improve performance, you take that logic, recode it in PL SQL, and then return the results. So you can do it in one call to the database. But for various reasons, practical reasons like lack of skill, time, whatever, you may not be able to do it. Do that complete rewrite. With the MLE, multilingual engine, you can pretty much take that code, Node.js, JavaScript code, put it in the multilingual, in a PL SQL block, and then it's all running in one call to the database. So you're eliminating a lot of that back and forth between the database. So there are some situations, and they probably more relate to practicality, skills of your team, and things like that. Perhaps not so applicable for people joining a SQL office hours, but maybe more applicable for more front-end developers with, you know, limited SQL and PL SQL expertise. Alrighty then, so that was what I had to cover today. There is a huge, as I said, 21C is probably it's the most exciting release, I think, for developers since I've joined Oracle back in 2015. Lots of cool stuff here, you know, lots of stuff I didn't really get a chance to talk about at all. Alrighty then, let's just take some of these other questions quickly. So, Anonymous. In a quick lookup in both 20C and 21C JSON guide, I don't see documented in the T-col new option that you have used in your example. Okay, so if we go back to that, new is the name of an attribute. It's not an operator or an expression. I've just literally called it new. So if you look in the JSON, if I just do return the JSON object itself, you will see there is a thing called new. It's not a JSON operator. I've added an attribute called new. Perhaps not the, yeah, new tends to get overloaded and so on and so forth. It's not a feature. It's just what I've called it. Okay, so I hope that explains it for you. Amit, would we be able to use JavaScript or Python inside SQL in the future, maybe like functions? This is the first iteration of this multilingual engine is the first iteration of this. There are plans to improve and enhance and expand this. JavaScript is the only language supported at the moment. Other languages may come in the future, and there may be options to do more cooler, more integrated in the database things than this MLE context stuff that we have at the moment. So stay tuned, Amit, see what comes in the future. Alrighty then, I'm not seeing anything else, you know. So that's me finished for this year. Like I say, I hope you all have a safe and happy holiday season festivities, end of the year, whatever it is you celebrate this time. And And I look forward to hopefully actually seeing some of you in person sometime next year. Stay safe and see you soon. Goodbye.